Hello, geometry students. I hope that everybody is having a wonderful day. We are in section 6-2 today, and we're talking about properties of parallelograms. What I'd like for you to be able to do by the end of this lesson is to use relationships among sides, angles, and diagonals of parallelograms in order to, solve for missing values. So we are getting into specific types of quadrilaterals now, and our first type is a parallelogram. Well, what on earth is a parallelogram? The definition of a parallelogram is a quadrilateral, which we know that's a four-sided polygon, so it's a quadrilateral with both pairs of opposite sides parallel. Now we are going to break down individual pieces of parallels as well, like the elements of what makes a parallelogram a parallelogram. So what are the opposite sides? The opposite sides are the sides that don't touch. Sides that don't touch. Opposite angles are going to be angles that do not share a side. Angles that do not share a side. And consecutive angles are going to be angles that follow one after the other in a parallelogram. So two angles that follow one after the other. And we're going to see what that looks like here. So let me draw a quick little sketch. Opposite sides in a parallelogram, for example, would be this guy and this guy. Notice how they are on opposite sides. Opposite angles in a parallelogram, so I'm just drawing just a generic parallelogram right here. They don't always look like this. But this guy, this angle would be opposite from that angle, just like this angle is opposite from this one. And then we have consecutive angles. So consecutive angles, if I were to draw another just generic parallelogram, consecutive angles, an example of that would be this guy and then that guy. And up here, let me kind of highlight that a little better. So there we go. So those are some images for you. Opposite sides, opposite ends of like the parallelogram. These upper and lower parts would also be opposite sides. Opposite angles are angles that do not share a side, so they're going to be on opposite ends of the shape. And then consecutive angles follow one after the other. They're kind of next to each other, sort of in the shape. Now I have a table here, and it's talking about properties of parallelograms. We're going to be applying these, and I'm also going to have a flow chart for you by the end of the chapter. But there are a lot of properties with parallelograms, so we're going to keep referring back to our table here. What are some things we know about parallelograms? First of all, what do we know about opposite sides? We know that opposite sides are parallel, meaning they don't touch. We also know they are congruent, parallel and congruent. That's the sides. What do we know about consecutive angles? So angles like this, where it's one after the next. Consecutive angles add to 180 degrees. In other words, they are supplementary. Opposite angles, though, are going to be congruent to each other. And then I have diagonals, and you have not seen a diagonal yet, so let me just draw kind of a quick little image for you. Let's say that this is our parallelogram. The diagonals would be these guys going diagonally through the shape. But there is a property of those as well, and they bisect each other. I'm going to actually say both bisect each other. And remember, the word bisect means to cut into two halves. So it forms two congruent halves. So we're going to apply these properties to help us solve for missing values within parallelograms. So we have opposite sides are parallel and congruent, consecutive angles are supplementary, opposite angles are congruent, and diagonals bisect each other. So we're really going to either set things equal to each other or add them up and set them equal to 180. That, once again, those are kind of fundamentally our basic options that we've got. So this one says in parallelogram CDEF, which is this guy, CD is equal to 74 millimeters. So I'm just going to label right here 74. DG is equal to 31, so this guy right here. And then the measure of angle FCD, so FCD is 42. I'm going to mark that like this, the whole angle, FCD, and then put a little arrow so we can see what we're talking about. That is 42 degrees. And we're going to try to find each measure. So first we want to figure out what EF is. So how far is it from E to F? Well, what I want you to notice here is that this is the opposite side from here. Now this is a parallelogram because we were told in the word problem. So from D to C is the opposite side from E to F. But we know something about opposite sides from our table. Opposite sides are congruent. So if from D to C is 74, then from E to F is also 74. Now we want to find the measure of angle EFC, which is this guy right here, EFC. We want to figure out how big that angle is. Well, once again, looking at our big parallelogram, the whole thing, this angle and then this angle are consecutive. Because they're consecutive, they're going to add to 180 degrees. So if I were to just label that X temporarily, then I can say 42 plus X equals 180, or I can easily just take 180 minus 42. When I do that, I am going to get 138 degrees. So let me box in my answers. There's my first one. Here's my second one. And now I'm looking for the value of DF. Okay, so from D all the way down to F. So this is a diagonal, so let's go to what we know about diagonals. Diagonals bisect each other. So in other words, this half is 31, but also this half down here is 31. Well, if half is 31 and half is 31, and I'm looking for the total DF, I just need to add them up, and I am going to get 62 for that value. We're going to keep applying these properties in the next examples on the back of this page. So in example 2, it says WXYZ is a parallelogram, find each measure. So we're using the same strategy. We want to apply the properties that are appropriate. We are first trying to figure out what YZ is. So from Y to Z. Well, once again, notice from Y to Z, this is the bottom side, and XW is the top side. These are opposite sides of the parallelogram. And we know opposite sides are congruent. So I'm going to write that. Opposite sides congruent. If they're congruent, that means we can set them equal to each other. So I have 8a minus 4 is equal to 6a plus 10. I'm going to subtract 6a from both sides, and that gets me 2a minus 4 is equal to 10. Then I'm going to add 4 to both sides, getting me 2a is equal to 14. In other words, a is equal to 7. But be mindful of what it asked me. It asked me for what the value of YZ is. So I'm figuring out this bottom part right here, not what A is. But A is a very valuable piece of the puzzle. I'm going to take this and stick it into the expression. So it's going to be 8 times 7 minus 4. Well, 8 times 7 is 56. 56 minus 4 is equal to 52. So I'm going to circle that for my answer, 52. Or box it in at least. Next, I'm trying to find the measure of angle Z. So that is this guy down here. Now I know that this guy is 9b plus 2, and then I know that that guy right there is 18b minus 11. I've only got two options. Either these guys are congruent or they're supplementary. In this case, because they're consecutive angles, meaning one coming after the next, they are supplementary. Because they're supplementary, they add to 180 degrees. So that's the equation I'm going to set up. I'm going to say this guy plus this guy is equal to 180. So I'm at 18b minus 11 plus 9b plus 2 is equal to 180. Okay, now I want to combine like terms, so 18b and 9b, and then negative 11 and positive 2. So that is 27b, 18b plus 9b, minus 9 is equal to 180. I'm going to add 9 to both sides. So now I have 27b is equal to 189. And divide by 27 on both sides. You'll probably need to get a calculator for that. I know I did. But when I do that, I get b is equal to 7. Okay, that's awesome, but I'm not done. If b is equal to 7, I need to take that and plug it back into my expression for the angle of z, because it's asking me for the measure of angle z, not for the variable, but for the angle. So let's stick that back in, and this is going to be 9 times 7 plus 2. Well, 9 times 7 is 63 plus 2 is 65, so I'm going to say 65 degrees for that final answer there. So the two properties that I applied in this problem are opposite sides are congruent and consecutive angles add to 180 degrees. These are the two properties that I've used thus far in that top example. In example 3, it says SRPQ is a parallelogram. What are the values of x and y? Because it's a parallelogram, and notice how x and y, they're on the diagonals, let's go to what that property is. Diagonals both bisect each other. In other words, the two halves are the same. So I know that this guy is congruent to this guy, and I know that this guy is congruent to that guy. Because they're congruent, I'm allowed to set them equal to each other. So I'm going to say 20 is equal to y plus 7, and I'm going to say 16 is equal to x plus y. Now, I want to start with this guy right here, the 20 is equal to y plus 7, because it only has one variable, and then I can use that value and substitute it in over here. So I'm going to subtract 7 from both sides, and I get 13 is equal to y. Okay, we're halfway there. Now I'm going to take this 13 equals y, and instead of writing y in the second equation, I'm just substituting it in. So this now becomes 16 is equal to x plus 13. I'm going to subtract 13 from both sides, and I get 3 is equal to x. Remember, when you have a variable in a problem, it's going to remain that same value everywhere it is. So y on this line is equal to 13, just like y up here is equal to 13. So that's why I was able to do that. So this property is both diagonals bisect each other when it is a parallelogram. Because they were bisected, that formed two congruent halves, which meant I could set them equal to each other. Okay, we have one more theorem to talk about, and this is talking about multiple parallel lines being cut by transversal. So it says, if 3 or more parallel lines cut off congruent segments of one transversal, then they cut off congruent segments of every transversal. So let's say we've got 3 parallel lines right here, and then we notice, oh, hey, this guy is congruent to that guy. Well, it doesn't matter any other line I draw in here. I could draw in another line right here. I could draw in another line, I don't know, right there. It doesn't matter. I'm always going to cut that into congruent parts. So this guy is congruent to this guy, just like this guy is congruent to that guy, and so on and so forth. But I don't want that image to get too complex. So when we realize, essentially what this is saying is this: when we have one transversal able to show that these three lines are evenly spaced, then it's going to stay that way across the whole image. Alrighty, so here we go. It says BE is, for example 4, it says BE is congruent to EA. So I'm going to mark that. BE is congruent to EA. If the length of CD equals 8, then what is the length of CF? So first of all, we've got parallel lines. They were being cut by this transversal, and this guy is also transversal, and it's being cut into a perfect halves as well. Now, I don't know that this guy is the same as this one. That's not necessarily true, but I do know that these two are going to be the same. I also know that CD, the whole length from here to here, is 8. And it's asking me for what is the length of CF. CF is this distance right there, basically half of it. Well, all I'm going to have to do is take 8 and divide it by 2. The reason I'm doing that is because I know 8 is divided into 2 congruent halves based off of the markings and based off of this previous theorem. So I'm going to have 8 divided by 2, which is equal to 4. So CF is equal to 4 there. Alrighty, that's everything that I have for you guys from section 6-2. I hope you have a great night, and if you have questions, bring them to me in class, and I'll see you later.